Okay, in this video we're going to be examining various integration techniques that we can use. The first one we're going to start off with, while it looks complicated, is just a U substitution. So what we're going to do is we're going to try to figure out what we can pick for U. Well, in this case, I kind of see a connection between the natural log of the t to the 6 plus 7 and then a t to the 6 plus 7 in the denominator. So what I'm going to do is I'm going to pick this right here as my U. All right, I'm going to pick that as U. I'm going to write it off here to the side, and let's see what that looks like. U equals the natural log of t to the 6 plus 7. Well, what is my du then in this case? Well, that right there is 1 over t to the 6th plus 7 times the derivative of the inside there, which is 6t to the 5th power dt. Okay, so I think I did okay. All right, because I see the 1 over t to the 6 plus 7. It's this t to the 6 plus 7 that's there in the denominator. I see a 6t to the 5th power. I don't see the 6t to the 5th power. I see a t to the 5th power dt. I'm missing a 6. So I can make that 6 happen right away. I can write the 6 there. I need a 1/6 right here on the outside. Okay, and so now I think I'm good to go. All right, I've got this right here that I'm going to put a ring around, and that represents my du, if you will. Okay, so now I think there's nothing to it as far as this integration is concerned, because I've taken something that looks very complex and I have turned this into a very simple power rule integral. All right, so what do we get here when we integrate? Well, we get 1/6 of u squared over 2 plus c, which when you work that out is 1/12 of u squared plus c. And then you can go back and do your substitution. 1/12 of the natural log of t to the 6th power plus 7 square, quantity square, plus c. And so we've got that done. All right, nothing to it there as far as the u substitution is concerned. So let's go ahead and take a look at another example. Okay, in this next example, it looks like it might be fairly easy to do, but in actuality, you really have to think about it. There's various integration techniques you can use. This one right here, probably not as obvious, but I'm just going to go ahead and tell you. In this case, you probably want to consider doing synthetic division. And what I mean by that is you're going to end up with some kind of remainder that maybe you can then integrate as well. So let's see what I'm talking about. If I do synthetic division, my denominator x plus 4, I write on the outside then a -4. All right, and then on the inside, I write the coefficients of the terms that are there, which in this case is a 1 and a 10 to represent the x plus 10. All right, and then this right here, since it's sitting on the outside, we set that equal to 0, and that's how I end up with the -4. Okay, so that's why we get -4 on the outside. So now, let's perform our synthetic division. We bring the 1 down. -4 times 1 is -4. 10 minus 4 is 6, and this right here is the remainder. And the remainder is always written over the divisor. So let's see what the new integral looks like. It should be 1, because it's again 1 degree less than what you started with. 1 plus, and then it's going to be 6 over x plus 4, and then dx. So we're going to take a look at that now in isolation. You can break up the integral, in other words. So you have the integral basically of 1 dx plus the integral of 6 over x plus 4 dx. Two separate integrals. The very first integral is very easy. It's just x. The second integral is the one that produces the natural log. So you can actually pull the 6 out over here, and you have 1 over x plus 4 as your u, in other words. All right, 1 over x plus 4. Actually, no, that's not u. the u is the x plus 4. Okay, so you end up with a 1 over u. All right, so x plus 4 du is just 1 dx. Okay, when you think about it there. So this right here, 1 over u, the integral for 1 over u, as you may recall, is just the natural log of u plus c. So that's what we're going to end up with here. But let's go ahead and take a look. So we've got for sure x plus, in this case, the 6 that got migrated across the integral. And 1 over x plus 4 is just the integral, is just the natural log of the absolute value of x plus 4 plus c. And what made this really nice was that the du was just 1, so we really don't need to account for anything else other than that. Okay, and so this right here then represents the answer to our integral question. All right, let's go ahead and take a look at another example, and we're going to take a look on this next example at an integration formula. Okay, so we're taking a look at this example number 3, but I want to point out first this formula for the secant inverse. Okay, it's an integral that produces a secant inverse anyways. And if you see here, we kind of just have to match up the individual components. All right, now understand here for a second that while it does have, for example, in the formula x on the outside and then an x square right here, okay, understand that that doesn't necessarily correlate to what needs to go on in the actual formula, if you will. For sure, an x sitting outside, that works for us, but what I'm getting at is the fact that this right here is a 36x squared and not particularly an x in this case. But we're going to use this, okay? Because what we need to do is we need to identify in this case, the x and the a, which we can do by taking the square root. So we're going to have here, in this case, 6x, and in this case 8. And once we've done that, we have enough information to pluck out to set up this integral using this formula. All right, so the formula says 1 over a. Well, let's recall that this right here was our a, and this right here corresponds to our x. Okay, so 1 over a in this case is going to be 1 over 8. There we go. And then it's the secant inverse of the absolute value, and then it says x, but in this case we know it's going to be 6x over a, which in this case was 8. Okay, and then plus c, your constant of integration. So this right here is as easy as it gets. You just have to be able to pluck out the appropriate information here. And I think we have time for one more example in this video, and we're going to take a look at that next. So in this last example, we're going to take a step back. We're going to think about all that we learned in pre-calculus, and hopefully you had a good teacher that went over all of the identities with you. This is one of those that I know I taught my students, and this is a double angle formula. So let's take a look at the integral that we're dealing with. We have cosine to the 7th power of theta times sine of 2 theta d theta. All right, it looks nasty, doesn't look fun at all, but what we have to remember is the double angle formula that we can get from here. So we're going to use this concept right here, and notice that I write recall. We're going to use that concept right there, the sine of 2 theta equals 2 sine theta cosine theta, in order to go about solving this integral. So let's take a look and see what that looks like. All right, let me change my pen color there. We have the cosine of 7 theta times, in this case, 2 sine theta cosine theta d theta. My 2, I can migrate it across the integral. My cosine, I can combine with this through multiplication. And let's see what that looks like now. I have 2 times the integral, in this case, cosine to the 8th power theta times sine theta d theta. All right, and now you should start seeing, oh, you're going to have to do some Usubstitution, right? So you can always rewrite this integral. You can say 2 cosine theta to the 8th power times sine of theta d theta. You can look at it that way so that you can set up your u substitution. So let's say that u in this case will equal the cosine of theta. All right, and since u equals the cosine of theta, du is negative sine theta d theta. All right, so we're going to have to write in then in this case a negative. All right, so let's go ahead and make that happen. So I'm going to put a negative there and a negative there. And now I can put my rings around what I know. Well, I know that this right here represents my u. And I know that this negative sine theta d theta right here represents my du. All right, and now that I've got that set up, I think I can rewrite the integral. And I'll rewrite it by saying I have negative 2 times the integral of u to the 8th power du. And then this becomes just a regular power rule integral that I know how to work with. And that is to say that this becomes negative 2 over 9 u to the 9th power, because it's u to the 9th divided by 9, right, plus c. And now that I've got all of that in place, I can back substitute. So I have negative 2/9, and then instead of u, I'm going to write cosine. So let me just write it as cosine to the 9th power. Cosine to the 9th power theta plus c. And that right there takes care of using a double angle formula and then u substitution to solve this integral that looked actually quite complex, but it's actually not that bad once you know what to do. Again, all of these problems required some kind of advanced integration technique, but you did need to know how to apply some of these formulas. So as always, I hope this video was helpful, and remember, like and subscribe.